Now we're going to look at an example of a smoothly rolling ball at x naught. What is x naught? X naught is a position at a certain time where that time is usually 0. So what does that mean? Well, let's take a look at Janice. We have Janice at 50 centimeters, and we're going to take Janice and we're going to move her uniformly down the track. Okay, so let's first start with the graph and let's plot Janice's journey. Did I just call her Janet? You know I meant Janice. I can't remember what I said. That's funny. That's how crazy I'm teaching online lately. So Janice, if I roll her uniformly, what does that look like on my graph? Well, first of all, I need you to understand that we're using a model. Rolling is actually way more complicated than what we're actually looking at here. So we're going to pretend like Janice is just moving smoothly, sliding down our track rather than rolling, because rolling is too complicated. So we're going to use a model of her rolling, but really we're talking about a smoothly moving ball at x naught. So we're going to change rolling to moving, and we're going to think about it that way and not worry about the rolling that's happening. So let's roll her and let's think about what's happening. At each mark of time, she's going to move up at the same amount of position. So at time 1, she moves up a little bit. At time 2, she moves up the same amount. At time 3, she moves up the same amount. So let's plot some things on our graph. Make sure you have time and position, and she's starting at 50 centimeters for her position. Now let's mark some equal time intervals, and then let's put in what's happening. So at each time, Janice is moving up equal amounts. So your position time graph for a smoothly moving ball at x naught should look like a straight line. It's the best straight line I could do, but it should be a straight line. And I think you understand that we have the same amount of position gained at each time interval. So what does that mean about Janice? Well, that means that our smoothly moving ball at x naught has velocity. What is velocity? Well, velocity is the rate of change of position with time. And if we think about velocity, we definitely know Janice has velocity as I push her. So next we'll take a look at the equation for velocity. Okay, let's discuss velocity. So velocity I'm going to often represent with a cursive V. I try to write it that way most times. Sometimes I forget, but mostly that's how I write it. Okay, so that's a cursive V. The units for velocity are meters per second, and we can actually find velocity by finding the slope of the position time graph. Time, position, look for the slope of that line. That will give you velocity in meters per second. So let's look at the equation. So here's our equation for velocity. We have x equals x naught plus velocity times time. So this is our initial position, but in order to find velocity, in order to figure out what our final position is, we need to add in how much farther it went based on its velocity and its time. So this equation allows us to solve for any one of those variables. It's very important to put a box around it and realize that x naught is where it started and Vt is how far it went. And you will use this quite often, and I'm sure you can see how it relates to lots of other equations that you've looked at before.